Here are three theorems about real roots of real polynomials. Descartes' rules of signs tells us how many possible real roots there are, and the theorem bounds tells us where they have to be in, the interval they have to be in. And these are called existence theorem. Basically, they don't really pinpoint where those roots must be. Theorem of rational roots is different. You actually make a list of possible fractional roots, which you can check. And so let's start with Descartes' rules of signs. And variation of polynomial is how many switches in the signs of coefficient have minus, plus, 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 minus, so that there are two switches. And Descartes' rule of signs said the number of positive roots must be this number or even numbers less. Okay, so it could be 2 less or 4 less. To find out how many negative real roots, we do this trick of investigating P of minus x, find out how many positive roots this one has, which in terms are negative roots of P of x. In this case, the variation of signs 2, therefore, there are 2 positive roots or no positive roots. Now, putting minus x into for P and look at the variation of signs for this one is 3. Therefore, this polynomial have 3 positive roots or 1 positive root, which in terms the original Px has 3 negative roots or 1 negative root. From this, I can conclude there must be 3 negative roots or 2 positive roots, or maybe no positive root. Therefore, the other 2 are complex. So I can sort out the different type of roots. Okay, where are those roots? Now, that's where theorem of bounds tells us. It says to find out where they are, you take the largest number, absolute value, then divide by the very first number and add 1 to it. So in this case, the largest number is 6 in the coefficient and divided by the first number 2. And that's 3, add 1, that's 4. So all the real roots must be between minus 4 and 4. So this, in terms of searching through calculator, is very easy because I just graph it between minus 1 and 4. I know all the roots must be in there. Okay, so I can trap all the roots. In this case, there are 3 of them. Therefore, the other 2 are complex roots. Now, rational roots tells us what the rational roots must be. They're fractions, and they must be b minus b over a. B must be the factor from here, and a must be a factor from here. So therefore, this is the list. If I know 3/2 is a root from this list, I can check through every one of them plus minus. If I know 3/2 is a root, then I can do synthetic divisions and break the equation down, and then I have come down to a quadratic, which I can use quadratic formula and find out what the roots are and the factor complete. Okay, and that's it. Bye-bye.